Welcome to this video. So in this video I am going to discuss KCET 2018 question number 21 to question number 25, right? So I am going to discuss 5 questions. The electrolytic refining is used to purify which of the following metals, right? So this is the from the chapter general principles and process of isolation of elements, right? So in the last topic there we shall see from crude metal we convert into purified metal, right? That process we call it as purification of metals, or refining of metals we call it as refining of metals, right? So there we discuss about distillation, liquefaction, electrolytic refining, zone refining, vapor phase refining, which consists of two methods. One is Mond's process, other one is Van Arkel method, right? So these are the things we are going to discuss, right? So first one is what? Distillation, liquefaction, electrolytic refining, right? The fourth one is zone refining, right? So this distillation is done for those metals which have got low boiling point. So for example, what? Zinc, cadmium, mercury, we do distillation. Liquefaction is done for those metals which have got low melting point. For example, bismuth, lead. For these elements we do liquefaction. Electrolytic refining is done for silver, gold, aluminium, this one copper and zinc. And this zone refining is done for semi-metals like boron, germanium, gallium, indium, silicon. For these we do zone refining. Mond's process is done for nickel, and Van Arkel method is done for zirconium and titanium. If you are able to remember these things, so you can easily solve even KCET, NEET and GE, right? So this is how I have given it. You can take the screenshot, or if you have read thoroughly, you can easily remember this, right? So the electrolytic refining will be done for which? Electrolytic refining done for silver, gold, aluminum, copper and zinc, right? So here our option is A. In JE they have asked which of the solution we use in silver gold electrolytic refining, right? So those questions will be asked in JE, right? That if I discuss those things, we can discuss about that, right? So this is about question number 21. Coming to question number 22. So what is this dry ice, right? So this dry ice, about dry ice you have learned in class 10th only. Dry ice is nothing but the carbon dioxide, solid carbon dioxide, we call it as dry ice, right? So CO2 is a gas that will be compressed such a way that the CO2 becomes solid. That solid will be like white color and it will be cooled, right? We have to decrease temperature and we have to increase pressure to convert gas into solid. So it will be dry ice, we call it as, right? So this is used for cooling purpose. So dry ice is nothing but the solid CO2, solid carbon dioxide. C is the correct option, right? So this is about 22. 23. Which of the following is amphoteric oxide? Right, amphoteric oxide. This is from the chapter D and F block elements. In that, when you are going to learn about metals reaction with oxygen, they forms metal oxide of various, because D block elements will show oxidation state from +2 to +7, right? +2, +3, +4, like that. Since they have got variable oxidation state, they do different metal oxide. So in metal oxide, some are like basic, some are amphoteric, and some metal oxides are acidic. Some metal oxides are acidic. So here question is which of the following is an amphoteric oxide? See, if you see the options A, B, C, D, you can see that little bit more confusion happens, right? To get the clarity how to solve this, so same questions will be asked in JE and NEET also, right? So if you are thorough with NCERT, you can easily qualify this KCET. If you are very thorough with NCERT, you can easily qualify NEET. And for JEE, you have to little work more, right? So see, here are the metal oxides. So I have told MnO, manganese oxide, is basic in nature, whereas Mn2O7 is acidic in nature. In between, all these are amphoteric in nature, right? All these are amphoteric in nature. Similarly, V2O5 is basic in nature. V2O3 is basic in nature. V2O5 is amphoteric in nature, and this will be less basic. Less basic means it is more basic, it is less basic. And here CRO is basic, Cr2O3 is acidic, whereas in between is amphoteric. So how I have remembered? I have remembered chromium oxidation state starts from +1, +2 to +6, right? Lower the oxidation state, that is +2, it will be basic. Higher the oxidation state, it will be acidic. In between what? Amphoteric. This is how I remembered. So manganese oxidation state start from +2 to manganese +7, right? So +2 will be basic, +7 will be acidic. In between oxidation state 8/3 +3 +4 are amphoteric, right? So this is how I have made the trick. Similarly, vanadium, lower oxidation state means basic, higher oxidation state here is amphoteric. Only vanadium, if you can remember, so star mark because of exception here now. Lower oxidation state is basic, higher oxidation state is amphoteric, in between will be less basic for vanadium. Whereas for manganese and chromium, lower oxidation state means basic, higher oxidation state means acidic, in between will be amphoteric. Similarly for magnesium, right? So this is, so the answer for this question is V2O5 and Cr2O3 are amphoteric in nature. You can see that here is V2O5, see V2O5 is amphoteric and Cr2O3 is also amphoteric, right? So if you can make the trick and remember this, you can easily solve this question. So coming to this 24, this is the direct question from coordination chemistry, right? So they have given this complex, we have to nomenclature this, right? So see, if I write this complex again, so it will be like cobalt, ammonia 4, Cl, NO2, right? NO2, overall charge is what? Overall charge is Cl, right? So it is like cationic complex because see, cobalt NH34 Cl NO2, if I put this complex in water, it will split like this. Cl will be having minus charge, so Cl minus, and this is plus. So this is cationic complex, right? So sometimes they will ask the question, which of the given following is a cationic complex, A, B, C, D. You have to know how to solve this, right? So this is cationic complex because in water, if I put Cl minus will come, plus will come, right? And here we know oxidation state of chlorine will be -1, and nitro group, nitrito, we call it as nitrito. Nitro group, it will be -1. So -1 plus -1 is -2. And it should be +3 because -2 plus 3 will be +1. So here is the +1. Overall charge is nothing but the charge of cation plus charge of ligands, right? So +3 plus -1 will be how much? To overall +3. So the complex charge is +3. So the cobalt is +3 here. So this is the complex. So nomenclature, first always we have to nomenclature the ligand. In ligand it is amine A, next comes chloro C and nitro N. So alphabetical order is A, C, N, right? So first I have to nomenclature this amine. So how many amines are there? 4. So it is, the name is tetra amine and chloro. We can write it as chloro or chlorido. Chlorido or chloro. In option they have given chlorido, so I have written chlorido. Chlorido. This is nitro, right? Nitro we call it as nitrito in coordination chemistry, nitrito. So here NO2 they have written. ONO, if they have written, the oxygen has bonded the ligand. Here they have written NO2, so it is N nitrito. It means nitrogen is bonding with the metal, electron deficient metal, coordination complex it is making. So N nitrito, it is cobalt. Cation means simple, it is cobalt. Charge is 3, outside we have chlorine, right? So chloride. So chloride. So this is the APAC name, right? So if we see tetraamine chlorido nitrito n nitrito, alright, cobalt 3 chloride. So this is the correct option, first one or the A. So this is the last question of this video. So one of the simplest question. Which of the following statement is true in the case of alkyl halide? Right. So we have two halides, alkyl halide and aryl halide. Right. So let me explain it. So alkyl halide means something like CH3, CH2, Cl. Right. It is nothing but ethyl chloride. And aryl means benzene ring. To that, if its chlorine is attached, that is nothing but aryl halide. So they have asked the question from alkyl halide. So let us discuss here. So this is alkyl halide, right? So this is organic molecule. So it will be water insoluble, right? But here option C, you can see they are highly soluble in water. They have given. This is not the true statement. They have asked the question is which is the true statement. So this is false statement because alkyl halides are water insoluble as they are organic, right? Organic molecule are water insoluble, right? They will be non-polar, so they are soluble in non-polar solvent. They are soluble in. What are non-polar solvent? Like benzene, right? These are all non-polar solvent. Toluene, xylene, etc. are there, right? And they undergo addition reaction. See, addition reaction will be done for double bond, alkene or alkyne, right? So here no double bond. It is simple CH3, CH2, Cl. So it doesn't do any addition reaction. So this is also wrong option. B. They can form hydrogen bond. No, hydrogen bond will be found between H and F. Only this halogen and which should be attached to hydrogen. Only this will form bond, not this. So this is not forming any hydrogen bond. They are polar in nature. No doubt they are polar. Because CH3, CH2, Cl is there, right? This Cl is an electronegative atom. So it takes the electron density towards itself. So it will be having delta minus charge and this will be having delta plus charge. Because of the electronegativity difference. What difference? Negativity difference. They are polar in nature. So the true option for the given question is A. True option is they are polar in nature. Thank you.